All right, in this video, we are going to work on another one of the interface practice problems, problem number 4. It says create a class named good that meets the following specifications. All right, so I'm going to create a class named good. It says the class should have fields called ID number and price. All right, so the fields should be either marked private or protected. For ID number, I guess I'm going to make it a string, and for price, I'm going to make it a double. It says the class should have a constructor that sets the value of each of its fields. So that would be public good, string ID number, double price. And then just set the fields the normal way. The class should have a toString method that returns a string showing the value of each of the fields. The toString method should not call any other method. So since toString is being overridden, I'm going to mark that as with the @override tag, and then just have to return a string out of here with the value of the fields. I'm going to use string.format, but you can use whatever you want. Just has to satisfy those requirements. So for price, I'm going to use the comma separators, .2f, and then it's ID number and price on that one. All right, so far so good. The class should have get and set methods for each of its field. The get and set method should not call any other method. All right, so public string get ID number. All that needs to do is to return ID number. Public double get price. At the very least, that one should return the price. And then public void set ID number. To do that, I'm going to need an ID number. And the very least this should do is change the value of the ID number field. And for price, I would need to know the price to set it. And the very least this one should do is set the price. And none of those call any other methods, so that's good. It says the class should have an abstract method named named description with return type string. Okay, so we're going to add in a abstract method. Remember, I have to mark it as abstract, right? And I should have a semicolon at the end of the method header and then no method body. When I go to compile there, though, right, that's going to cause an issue because of the fact now my class has an abstract method. It says good is not abstract and does not override abstract method description in good. So my class has an abstract method, which means that it must also be marked as abstract. So I don't have any choice. If this is going to have an abstract method, the class has to be abstract. No way around that. So to follow the directions, that's what I would have to do. Okay, so then it says the class should contain no other fields, constructors, or methods other than those listed here. Check. Should not implement any interface. Check. Should not extend any other class. So all that is done. So next up, it says create an interface named taxable that meets the following specifications. All right. So new Java, and then public interface taxable. And inside here, it should have a constant of type double initialized to 0.06. So double tax rate equals 0.06. Remember, I have no modifiers in front of this, but it's public static final by default, right? Constant. So I don't need to put that in an interface. It's just automatically assumed. And then the other thing is the interface contains an abstract method named calculate tax with return type double. So here I would have double calculate tax. And again, it's public abstract by default on methods and interfaces. I don't need to put that. So that's all I need in that. The interface should not contain any additional methods besides those listed here. Done. All right, next up, create a food class named food that meets the following specification. It's a child class of the good class, implements the taxable interface, and has a field named calories of type int. So public class food. All right, so it's a child class of the good class, and it implements the taxable interface. And it has a field of type int, I think it was, calories. Yeah. That reminds me, before we go any further here, right, back under good, I made these private, right? They should be private or protected. And so for these, this class, since I know it's going to be a parent class now, I'm going to change those to protected. That way the child class has access to these fields. Whether we actually use that or not, it doesn't even matter, right? These should be private or protected. The only good reason for not being private, right, with Java is that it's going to be a parent class. And so this one is going to be a parent class, and so change these to protected. Okay, so now here we're ready to compile. We're going to get some errors when we compile this, right? This is not going to compile because there's some things that we have to do in order for it further. Number one, it says food is not abstract and does not override the abstract method description, okay? So in other words, hey, food is a child class of the good class. Good has an abstract method called description. You either need to put an implementation of that, which is what we are going to do, right? So public string description. The other thing that to get rid of this error is to mark this class as abstract. But the minute you do that, what's going to happen is that you cannot create objects from that class. And later on in this problem, it's going to ask to create objects from this class. So that's not an option here. So we need to return something. And again, this does not have to be elaborate description, right? For the purpose of these practice problems, it's a food item. Okay, so that will take care of that issue that we didn't have description in there. But again, we're going to have the same issue, right? And this time it's with calculate tax. That's in the interface taxable, right? It has an abstract method, calculate tax, and it's saying, hey, you said that you want to declare that implement that interface, but you haven't provided a calculate tax method. So we're going to have to do that. Public double calculate tax. And there might be some details in here at the very least, right, to get this to work. Well, it returns 0 out of there. Okay. And so you can see that fixes that error. We get a different error. Later on, they might have some, in the statement of this problem, they might want us to do this a certain way. Okay, so next error that we get, right, is constructor good and class good cannot be applied to the given types, right? And so what that is saying is that, hey, the parent class good only has constructors with parameters, right? This has 2 parameters. So the child, that means that the child class must have a constructor in there. And it must provide those values to the parent before the child can be created, right? The parent has to be created before the child has to be created or can be created. So the child is going to need to know the ID number and the price up front. So we're going to put that here. Also in this constructor, we'll want some value for the calories as well. So for those first 2 fields, ID number and price, right, those need to be passed on to the parent. Remember, super, right, always refers to the parent. So this is basically passing along the ID number and the price to the parent. And then the calories field is only in food and not in good, so we just set that one the normal way, right? This dot calories equals calories. And that takes care of the constructor. Okay, next up it says the class should have a toString method that returns a string showing the value of each of its fields. The toString method should not call any other method other than methods in the parent class. Okay, so make the toString here at override public string toString. And then we need to return a string out of here. That string needs to just have the values of ID number, price, and calories in it. You can do this anyway, but I'm going to use string.format. I'm going to put a placeholder for a string here, and then I'm going to put the parent toString, what it returns in that spot. And then the other thing, the new thing for this is calories, and that is an int, right? So that should do it. And then in the first spot, I'm going to put super.toString. So that will call the toString method in the parent and return this stuff, the part for ID and price. And then I'll go right here in this spot. And then in the second spot here, I need calories. And that's it on that one. All right, so that's the toString done. Get and set methods for each of the fields. All right, so there's 3 fields, ID, number, price, and calories. But the get and set methods for the ID number and price are in the parent, right? And since food is a child class, those it inherits automatically. So unless you're changing those, right, you should not put them in to this class. If you're just using the default ones, just keep it like that. So you don't need to add it. In fact, you should not add those in here, right? Otherwise, then if you want to change something, you'd have to change it in all the classes instead of just one. So all we need to do is to add the get and set methods for calories, the calories field. And for set calories, I need to know the calories to set it to. And then the very least this should do is set the value of the calories field like that. All right, so that takes care of the get and set methods. All right, so the implementation of the calculate tax method should return 0.0 since food is not taxable in some states, right? It's not taxable. So we're good, right? Calculate tax method is 0 here. So this one is done. All right, next one, toy. All right, it says create a class named toy that meets the following specifications. It's a child class of the good class. It should implements the taxable interface. It has a field called minimum age. So a class named good, it is a child class of the good class. It implements the taxable interface. And it has a field, let's see, minimum age, so that's probably an int, right? And we're going to encounter those same exact problems, right, that we did in the previous one. Oops. I hope I didn't mess that up. This is toy, not good. There we go. We're going to get those same 3 errors, right? We didn't implement the abstract methods in good, the description method. We didn't implement the calculate tax abstract method from taxable, and the constructor is not set up correctly, right? So all 3 of those things. So first, the description. Okay, so right, good has this description method. It's abstract, and toy, being a child class of good, has to have an implementation of it, or we got to mark it as abstract, which we don't want to do. So that takes care of that one. Calculate tax, right? Here, toy is implementing the taxable interface, and it has an abstract method called calculate tax. And at the very least, we have to return a double out of here. So for right now, we'll return 0.0 just to fix that issue. And then later on, we might have to change it, right? Last time we didn't, but this time I think it's probably going to calculate some tax on there. And then we have that same constructor issue, right? Constructor good and class good cannot be applied to the given types. The parent class good has only constructors with parameters, so you're going to have to supply those values up front. So public toy. And good had 2 parameters, ID, number, and price, right? So same things. And it also has this minimum age, which we should include. And so we need to pass the values that the parent class needs, which are ID, number, and price. And then the minimum age is only in the child class, so we just set that one up as normal. All right, so that took care of those issues. Next up, the toString method. So similar to what we did before, at override public string toString. And I'm going to return string.format. And again, leave a place for the super toString. And then put something for minimum age. Minimum age is an int, so the placeholder for that is %d. Then I'll call super.toString, right? That will return this bit about ID, number, and price, which I will put in this first area here. And then in the second placeholder, I'll put minimum age. Minimum age. All right, so there's the toString. What next? Get and set methods. So this class has 3 fields. It has ID, number, price, and minimum age. The get and set methods for ID, number, and price are in the parent class. So this class inherits those automatically. There's no need to redo them. In fact, you shouldn't do them unless you are actually changing them like we did in the toString. Okay, if we're just using the same get and set methods, which we are, you can just leave those. So all we need to do is public int get minimum age. And the very least this should do is return the value of minimum age field. And the set minimum age, we need to know the minimum age to set it to, so I need a parameter for that. And then the very least this should do is set the minimum age. Okay, let's see what else. All right, here we do have some information about the calculate tax field. It says the implementation of calculate tax method should return tax based on tax rate, constant, and the price field. So back up here and calculate tax, that's going to be price times tax rate. Price is a field, right, of toy, and tax rate, remember, is in the taxable interface right here, 6% tax. Okay, so we're done on toy. All right, another one. Create a class named book. All right, and it says book is a child class of the good class, implements the taxable interface, has a field named author, right? So it is a child class of the good class, so that's extends good. It should implement the taxable interface, right? It has a field called author, so that should probably be of type string. Again, we're going to get those three issues. Book class is a child class of good, right? And good has an abstract method in it, so we have to provide a description, right? So public string description. Again, you don't have to get too elaborate on this. There's lots of better things we could do, but the very minimum, right? Something like this. Again, same issue for the calculate tax method. So public double calculate tax. And I have a feeling it's probably going to be exactly what we did before, which is tax rate times price, right? So let's just go ahead and do that. And then the third issue, right, is the one with the constructor, just like we had in the first two. So public book will need fields for ID number and price, and also for the author field, so that's string author. And then we'll need to set up the parent first, right, with the call to super and pass along the ID number and price. Those are the two bits of information that the parent class needs, right, to get itself set up. And then for the author field, that's not in the parent, so we just set that up like normal. So that should compile. All right, so good to there. Constructor that sets the values of each field, check. The toString method. So mark it with the override tag, and I'm going to do this one exactly the same way as I've done the others here. Again, you don't have to do it this exact way. Just need to make sure that you return a string out of there with with the values of the fields in there. So in that first spot, I'm going to call the parent class toString, and put that in the first blank, and then the author in the second blank there. All right, get and set methods for each of its fields. Again, this one has 3 fields: ID number, price, and author. Because the fact that it's a child class of good, the get and set methods for ID number and price are already inherited. So do not put them in there again. The only reason for doing that would be if you wanted to customize those get and set methods to do something slightly different for book, and didn't say anything about doing that. So we're just going to keep the same ones we have. That means we just need get and set methods for the author. And those are standard. Just doing the bare minimum here, which is all we have to do for this problem. Public void set author. If I'm going to set the author, I need to know what author I'm going to set it to. And then the very minimum, right? Just set the author field to whatever is the value of the parameter. All right, so there's the get and set methods done. Calculate tax should return the tax based on the tax rate constant in the price field. That's exactly what we did. Same thing as before. So we've already done that part of it. So we're good to go on this one. All right, next up, demo good. It says the class should contain a main method. So put the class header and body, main method, public static void main. Put the main method header and body. All right, next up it says the class should create exactly one array containing 2 anonymous food objects, 2 anonymous toy objects, and 2 anonymous book objects. So I want to put all 6 of those objects in a single array. They have different types: book, toy, and food. So to be able to put them into a single array, that means I need to make the array either of type taxable, because that's possible because all 3 of these classes implement the taxable interface. The other thing is I could make them all of the array of type good, because all of these classes, food, toy, and book, are all child classes of the good class. So I'm just going to choose good. Okay. And I'll call this goods. And so there's the start of my array, and it wants some anonymous objects. 2 anonymous food objects. Okay, so anonymous just means that I create those objects, but I don't put them in any one particular variable. So here I'm just creating the object. So I need an ID number, I need a price, and I need some calories. Same thing, do another food object, ID number 1, and I'm just making these values up. Price 678 and calories 723. So there are my 2 food objects. Next I need 2 toy objects. New toy, I need an ID number. 2, I need a price, $19.99, minimum age 7. Another toy object, toy, ID number 3, $5.29, minimum age 2. New book. ID number 4. Price $9.99. Author Watt Evers. And then another book, new book. ID number 5. Price $14.99. Author Alice Atwater. And looks like I'll need another closed curly brace in there. All right, so there is my array with my 6 anonymous objects in there, okay? All right, next up. It says the class should contain exactly one for loop that prints the objects in the array, 1 per line. So for good, colon goods. All right, so for each good of type good in the array goods, then we need to print that out, right? 1 per line. So because we have all this toString set up, we just need to do system.out.println good. Oops, I did print. I want a 1 per line, right? So println. All right, so that looks good. Everything's set up there. What else does it want? It says inside the for loop, call the description method in each object. All right, so system.out.println, right? I just put good, and then I dot, and then I call the method there. All right, so it puts the description. And then the last thing is I want to call the calculate tax method. All right, you see when I do that, right, I get this error message. Cannot find symbol, calculate tax, okay? Which is a little bit weird when you first see it, right? Because you see, hey, look, there's calculate tax right here. And toy class, it has calculate tax. And food, it has calculate tax. So this is saying, Java's here is saying, I've never seen calculate tax method in food, toy, or book, right? Which you can see is not true. It's right here. So the situation here, what happened is that in order to store these items in a single array, right? We either had to use taxable or good, right? And we chose good. Just it didn't really matter here which one we chose. This problem was going to surface one way or the other. So we chose good, right? And so you'll notice the description method, right? You can see that's in the good. That's in the good class right here. So Java had no issue with that, right? We put all of these things in the array, in this array good. Java now is thinking these objects as being of type good, right? So it goes to call the description method, and Java checks and looks, oh, it's right there. However, in the next line, right, when we go to call the calculate tax method, remember Java is thinking of these objects as being of type good, right? And so you can look in the calculate tax method is not in the good class, it's in the interface, right? And so Java is not able to figure that out. So the fix for this, right, is to cast this as good, to remind Java that, hey, good, it is of type good, but it's also, these objects are also implement the taxable interface. So what we can do is cast to the just a second. All right, sorry about that. I had a minor minor emergency, so I will edit that out after, hopefully. Okay, so the issue was calling this calculate tax method, right? Java can't find it because of the fact that we stored all these objects in the good array, and so that method is in the taxable interface, and so Java doesn't know where it's located. So all we've got to do is to remind Java that good, right? All these things, all these objects in here, they are also implement the taxable interface. So you can do that with a manual type change, right? So change this to taxable. You can see that's not going to be quite good enough, right? When you do it like that. And that's because the order of operations here. So what you've got to do is surround this also with another set of parentheses and change it like that. All right, and so then you are fine with, Java is fine with it, right? So we're telling it, hey, the things in this array, right, which is represented by good here in this loop, change it to a taxable object, which it is, right, because all of these implement the taxable interface, and then look inside there and you'll find the calculate tax method. And Java goes, oh yeah, I see it. Okay, great. And it will call it will do that. So now when we run it, right, we should see we get those, the taxes right here, okay, listed out, and the descriptions. All right, so I think that is it. And so therefore, that's it, and that's all for this one. So let me know if you have any questions.